This is the fabrication of a simple test tube that has a 2440 female joint at the top. The reason why is I want to use it for storing a very corrosive chemical, gallium 3 chloride, which if you use a stopcock that has vacuum grease, it will corrode it. It'll seize it. And I have specialized Teflon stoppers that I can use. I could use a Schlenk flask for this instead, except that the ground glass interface for the stopcock on a Schlenk flask has vacuum grease. So that's why I'm constructing this test tube. So I've got the 2440 blank in attached to a longer piece of glass that has a 2440 male joint that seats into it. That's basically to give me a handle. And so I'm heating the end of it, and the length of my final test tube, it really isn't critical. So I'm not too concerned that I basically am going to remove about 1.5 inches of glass at the bottom. I probably should have taken the time to set up a brace to make it a little easier while I'm doing the rotation, just because of how long that piece of glass is, the glass tubing that I'm holding it, which is why I kind of switched from one side to another. What I'm really trying to do, and failing at, is keep the glass uniformly heated while it's in the flame, so that way it stays on center. I don't quite get that done. I'm kind of blocking the angle, but you'll see it in a second. I don't quite keep it on center. You can see it's a little wobbly, but that's okay. When I remove the glass using the tweezers, I will pull it into center, and then eventually, when I blow it out, it'll be okay. And honestly, for this particular piece of glassware, it doesn't have to be perfectly centered. It doesn't have to look very pretty. When all is said and done, it simply has to be a sealed tube that I can put a Teflon stopper on. So I wasn't, like I said, too concerned, like right here when I remove the glass, that it's a little off center. At this point, I'm going to heat up the glass again, and I'll be putting a blow hose on. That way I can recover the shape of the test tube. So right now it's caved in quite a bit, because when I remove the glass, it was open, so there was no point in putting a blow hose on there, because you can't blow through it. Now that it's closed, I'm going to go back in. I'm going to reheat the end of it, which is again lopsided. And right here, I'm pulling off a little nib of glass. Basically, it's extra glass, and as I pull it off, I can bring the remaining glass back centered, or center it a little bit better by doing that. And so now I'm going to basically get that end heated up again. I'm using the Stax Bethlehem burners that we have. The Stax have an alpha burner on top, and then it has a burner that's equivalent to a Bravo. So right here, I'm doing I've heated it and I've blown into it. A little bit later on, I'll show the second heating and where I blow into it, but I'll magnify that to show you how it's recovering its shape. And that should happen any second now. So yeah, I'm heating it, and then I blow into it, and you can see it's getting the shape back. It's a little off center, but it's fine. I actually zoom in it again just to emphasize that that step of blowing into it is critical. So at this point, I'm just going to reheat it and make sure everything is as nice as I can make it. And then I'll hit it with an annealing flame to minimize the stress. Honestly, for this particular test tube, the annealing flame's probably not necessary, and I do run this through the annealing oven a little bit later. So I am actually also making one last really tiny adjustment as far as blowing into it. I don't think at that point it actually made any difference. So now I'm going to hit it with the annealing oven, or the annealing flame, excuse me. Again, to help minimize any stress. This, I believe, is a standard wall tubing. It's 2440. I don't know what that diameter is specifically. I would guess 24 millimeter, something like that, in that ballpark. And this was actually a piece of glass, glass blank, a 2440 blank, that I found in my research lab. In other words, it had been bought by another professor, decades ago, and was just basically new in the box, even though it was very, very old. But it works great. So right now, and I'll show it, I'm taking the glass that I've just heated and shaped, and I'm putting it into fiberglass blankets to let it cool down. So I'll swing the camera around. And then next, I'll actually show what it looks like after it's cooled down. So you can see that brown line, that is glass stress, and now it's been annealed, and so the stress is gone. I actually made 2 of these, and that's what it basically looks like when it's doing its job of having the stopper in.